All right, so test your understanding number 2. A person traveling 40 meters per second in a car encounters a reason to make an emergency stop. It takes the person 2 seconds, while traveling with a constant velocity, to react and apply the brakes. And then the car comes to rest with an acceleration of magnitude 8 meters per second squared. Determine the total distance and the total time required to stop. All right, so first let's identify these segments here. What's happening? In this first one, are we accelerating or are we moving with a constant speed? We're moving with a constant speed while we are reacting. So this is the reaction time. This is the time it takes for the brain to think and then move that foot from pedal to pedal. And then once we actually do slam on the brakes, this is where we are. So we're braking or accelerating. So you can look at it. This is the constant velocity and this is the braking velocity. Let's write in the information that we already know. We know the starting position. We're going to go ahead and call that 0. And then we're going to say the starting time is 0. Good. What about the starting velocity? According to the problem, 40 meters per second. So how long does this constant velocity go for? Ooh, constant velocity, that means our final velocity here is 40. That means it goes for 2 seconds. Great. We have a time interval. What else do we know? We know the acceleration here is 0. Okay. We're going 40 meters per second for 2 seconds. So we can use x, or displacement, equals v times delta t. So 40 times 2 is going to give me 80 for my displacement here. That means my ending position is going to be 80. And then the time here, clock time, is 2 seconds. Great. So now this is our starting stuff, and this will be our ending stuff. What are we going to end with? Let's see. We know the velocity that we're going to end with is going to be 0. So we're going from 40 meters per second to 0. How long does it take? That's what the question's asking us for. Displacement, that's what the question's asking us for. All right, so let's figure out this this time right here, because once we have this time interval that it takes to brake, then we can go on, we can find anything else. Oh, I missed something. It's staring right at me. Acceleration is a magnitude of 8 meters per second, right? 8 meters per second squared. We'll go ahead and write that in. But wait, we're braking. So let's not forget that it is a negative 8 meters per second squared. Okay? So now xt, vt. All right, let's do it. So let's use our velocity as a function of time. Vf equals vi plus at. We have acceleration. We have our starting velocity, which is 40, and we have our ending velocity, which is 0. So we can go ahead and substitute from here. 40 plus 8 times t, and then you get negative 8 t, right? So we're going to move 40 over here. So we now have a negative 40, and then we'll divide by negative 8, divide by negative 8, and we get a time of 5 seconds. 5. So what is the clock time reading at the end of all of this? Well, 2 plus 5, that'll give us 7. Now for our displacement, I'm going to go ahead and erase some of this junk here. If you need it, just go back. It's a video, it's not live. All right, so now we have final velocity, we have initial velocity, we have a time. We can go ahead and get displacement using our regular old displacement formula, v delta t, where delta t is 5, and our average velocity between 40 and 0, 40 plus 0 is 40, divided by 2 is 20, times 5. So our displacement is going to be 100 meters. So displacement is 100 meters plus the 80 that we started this segment from. So our final position is 180 meters. Cool, right? Right. the correct answer is correct. All right, so we are reacting, so we are moving with a constant velocity here. So when we go over to our position versus time graph, for these first 2 seconds, we have a constant velocity of 40. So we're going to rise by 40, 2, 4, and run by 2 seconds. Okay? And for the second segment, we're going to end at 180 meters and 7 seconds. 180 meters and 7 seconds is going to be right there. Okay? And we're accelerating, so there's a curve to it. That's not great. This should look a little bit cleaner. It should be connected, but for time and space, that's what I did. Please make sure you don't do that. All right, so for the first 2 seconds, we have a constant velocity of 40 meters per second. There we go. There we go. And then what is our velocity doing? It's decreasing, right, at a constant rate. So at 7 seconds, we should end up with a 0 velocity. Oh, give me a break. 7 seconds, we should end up with a constant velocity. There we go. The straight lines are so much easier to work with. And then for our acceleration, we start off with 0 for the first 2 seconds. And then the acceleration is a -8, ending at 7 seconds. So we're going to have -8, ending at 7 seconds. Little vertical line there to connect them, and boom, we're done.